Hello everyone, my name is Professor Tim Coates and this is a video presentation on classes and objects. What we're going to do in this video presentation, we're going to use the Java language and we're going to create a class. Inside of that class we're going to add things like fields, accessor and mutator methods, constructors, and some additional methods. And then once we have our class built, we're going to test it out by creating objects from the class and calling the methods within the class to see if they work properly. Now, all of this material that we're looking at today is in Chapter 3 of your Java textbook. If you haven't read the chapter yet, I would suggest that you take a look at it. I'm going to mention as we go through some of the terms that you'll need to understand as we go, but you definitely should read the chapter too along with this lecture to kind of complement it. So that said, when we think about object-oriented programming, typically what we do is we take a program and it contains a set of classes. And a class represents a real-world entity. Things like customers, products, weapons in a video game, characters. Whatever it is you're building, basically, you take a look at what you have to represent in the program, and you write down all of the entities that the program interacts with or deals with. So if we're talking about a bank account, really it's pretty simple. You have the bank and you have the customer. And the customer comes into the bank and says, well, I want to start banking with you. And the teller says, great, let's set up for you some accounts. Typically they'll they'll set up a checking account, a savings account, and some other things, but fundamentally they're all accounts. So we need to think about creating an account. Now, rather than creating all three of these classes, I'm just going to focus on account in this video. So if we look at account and zero in on that, our goal then is to design a class to represent a bank account. Now, what are some of the things that we need to know about a bank account? Now, the reason I'm asking that is because of the definition of a class. A class is a blueprint for an object. And as you go through the chapter and read about this, you'll hopefully get a better sense of what that means. But you start out with a class, and the class isn't the actual thing that you run. The class is used to create an object, and the object is the thing that you run. So your class is essentially the design schematic for the objects that you build from it. So knowing that, when we make a class, essentially these are going to turn into objects. Now an object essentially is like a box. And the box encapsulates, or we could say contains, data and what I'll call behaviors. First of all, the data. An object has data in it. So in our case for our bank account, one of the pieces of data in our object would be the balance of the account. Another piece of data would be the name of the customer. And if this were a savings account, you may have an APR, and there's going to be various things that you'll have to store for that object. And that's what we mean by data. Now, when we create variables inside of a class, those variables are called fields. Now, fields by definition are private. So what we do is we create these variables, and if you think about a box, you're putting these variables in a box, and you're hiding them from the outside world. Now, you don't want to hide all of the variables, but by default they're going to be hidden initially. So if we hide our balance, it's not going to do anybody any good. So we need to expose it, but when we expose it, we're going to go about it carefully, because by exposing the balance to the outside world, there's two things that can happen. You can either ask what the balance is, or essentially read it, or you can try to set the balance, or what we call write it. When an attempt is made to write a value to the balance, we don't want to let that number be set to a negative value. So we want to put a restriction on the range of the balance. That restriction needs to be imposed by writing code, and that has to be done inside of the class. Because that restriction has to exist, we're going to make our member variable or field here private, and then we're going to create a getter, or we'll call an accessor, and a setter called a mutator to read and write the field. So in the case of the balance, we would create a field called balance. Then we would create a getter. And in Java, what we do is we name this get balance, like that. So we take our field and we keep it lowercase. Actually, what we use is the camel case convention. So it's a lowercase words. Well, let me back up. The first word is lowercase, and then all subsequent words are uppercase. So in this case of balance, the first word is lowercase, and there's only one word. Then the name of the getter, you simply put get in front of the variable name. So get balance, and you capitalize the B. We would also create a setter called set balance. So if the user wants to change the balance, they have to call set balance. Our set balance function is going to require that the balance they want to set it to must be a positive number. So we have an object which is like a box, and inside of our object we have these hidden variables. They're hidden, and yet they can be exposed. They are exposed through getters and setters. Getters are called to read the values. Setters are called to write the values. The reason that we do this is to protect the integrity of the data inside of these variables in our objects. Now, an object has characteristics or behavior, but it also has functionality or capabilities. So an object has properties, characteristics, attributes, which are essentially private variables in the class. An object also has behaviors. Which we would call, in our case, in Java, methods. A method is simply a function within a class. That is the definition of a method. Methods are public functions in a class. So when we talk about building a class, we build our private variables, which are called properties, characteristics, attributes. Oh, I knew I forgot one. Fields is another term that we'll use. So we have those characteristics, and then we have our behaviors, which are things that the object can do. So essentially, an object can know things and can do things. And that's the bottom line. You want your object to be able to store or know things, and you want it to be able to act upon its data or do things. So the fields that we build take care of the things that it knows, and then the methods that we write take care of the things that it can do. So what I'm going to do next is I'm going to put together a specification for the class that I want to build. And the specification, and there's no real standard way of doing this, so I'm just going to show you how I typically do this. I simply type out how I want to build my class. So what I need first of all is I need to know the name of my class, and I'm going to call it account because it's a bank account. Then I want to know what fields, again, fields are private variables, so what fields do I want to store in my class? And we've already talked about the fact that I want to put a customer name inside of the class, and then I also want to build into it a balance. So those are my two fields. What about methods? Well, first of all, I know that I'm going to have getters and setters for my fields. So I'm going to start with my getters and setters. So I'm going to have, first of all, for a customer name, I'll have a get customer name method and a set customer name method, a get balance, and a set balance. Okay, so since I only have two fields, I only need two pairs of getters and setters, which gives me essentially 4 methods that I have to build. I also want to create some additional methods which enable us to deposit funds, and another one to withdraw funds. The idea here is that you're going to pass in the amount you want to withdraw or deposit as parameters into the methods. When you look at getters and setters, getters simply return back to you the data type of the field that you're requesting. So get customer name is going to return back a string, and get balance is going to return back a double. With setters, there is no return, so we put void on the return types for the setters, and you pass in the name that you wish to set the value to, or in the second case here, the balance that you wish to set into the object. Now this set balance call is going to accept a balance, and it may or may not take it. It will only take it if it's a valid value, which you'll see here in a few minutes. Finally, I want to add a few constructors. But now again, a constructor is what's called when you create an object from the class, and the first constructor I want to have is the default constructor, which takes no parameters. The second one, I want to let it accept a name and a balance. So when the user goes to create an account, we want to give them the ability to create it empty or create it with a name and a balance. And that takes care of that for us. So those are the specifications for my class. So let's say that I write this thing. How am I going to test it? Well, I need some sort of a strategy for testing. I'm going to create another class. And I'm going to call it Account Manager, because ideally you would be building a class that would be able to add, edit, or delete these accounts, i.e. manage them. So if I create this Account Manager class, I want to give it a main method. So when I run the program, I have a starting point. going to go into the main method of this account manager class. Now, within that method, we want to create an account object. And then what we want to do is to test the methods of the object to make sure that everything works properly. Now, when we do this, we typically build a set of scenarios called use cases. And what a use case is you basically do something to the object and you expect a certain result to occur. And you simply check to see if that result occurs or doesn't occur as you expect it to. So for example, let's say that we go to construct an account and we pass in a balance of 200 and we pass a customer name of Joe Smith. So this is the action here. These are the values that are passed in. And then we have the expectations, or expected results, in this third column. So when we create an object and we pass 200 in for the balance, we would expect the balance to equal 200, and we would expect the customer name to be Joe Smith inside of the object. That's basically what that means. Now let's say that, okay, we know that works. What about testing our deposit and our withdrawal methods? So we begin by saying, let's try to deposit $500. What would we expect the result to be? Well, the balance we would expect it to equal 200 plus the 500 we're adding, or 700. Now we want to test the case where we try to pass a negative number to the deposit method. That should be an invalid value. You should never be able to deposit a negative value. So what we would expect to see if we try to do this is that our balance equals 700. In other words, it's not going to change. It was set to 700 after our $500 deposit with an opening balance of 200. Since that made the balance 700 and now we're trying to deposit negative 500, that should fail. And so our balance should remain 700. Okay, now we tested our deposit method. We tried to give it something that was valid and something that was invalid. Let's do the same thing with our withdrawal method. So first of all, what if we try to withdraw negative $300? Well, that should give us a balance of 700 because the value will not be changed. The reason is a negative value. You can't pass a negative value in to the withdrawal method. And in fact, that was also the problem with the deposit method above it. Negative values are not allowed, or at least they won't be once we build the class. So then we can try withdrawing a positive 300. That should give us a balance of 400 because it's a positive number and it's not out of range. But what if we try to withdraw $1,000? Well, that's a positive number, so in that sense it's valid. But what's the problem with it? It's too high, right? It exceeds our balance, so that's going to be a problem. So in this particular case, our balance should remain at 400. Reason being, value exceeds balance. If we look at the use cases that I've listed out here, we will have tested everything up in the list up top. And that's essentially what you want to do. You just want to make sure everything works. However you test it, that's really the bottom line, is you just want to make sure everything is working properly. So that is our specification, our testing strategy, and our use cases that we want to do in this particular project. So with that, it's time now to jump into IntelliJ and start building this thing. So I'm going to switch screens and head into IntelliJ at this point.